Okay, hello everyone. My name is Kelly Dudley with the New Center. I'd like to welcome you to today's webinar entitled An Overview of Sustainable Concrete Design, and we're glad you could join us. A video recording and PDF of the presentation you're about to see will be uploaded to the new website, newconcrete.org, following today's webinar. Attendees, you are in listen-only mode. You may ask questions during the Q&A in the Zoom platform. Our speaker will be happy to address any questions at the end of this presentation. An overview of today's webinar is shown on the screen and is also listed on the new website with the webinar series information. And now I'd like to introduce you to our speaker. Andrea Schokker is the Senior Technical Consultant and Advisor to the Board of New. She is also on the engineering staff with ACI. Prior to joining ACI, she spent 14 years as a professor at the University of Minnesota Duluth and 10 years on the faculty at Penn State. She holds a PhD in structural engineering, is a licensed professional engineer in Minnesota, and is a LEED accredited professional. She has authored 2 books on sustainable concrete and was the founding chair of ACI Committee 130 on sustainable concrete. And now, I'd like to hand the presentation off to Andrea to get started. Thank you very much.
Thanks, Kelly.
Sure.
All right. Well, I'm going to say hi and then go ahead and turn my camera off so we can focus on the slides here with that and use all of our bandwidth properly. But I'm very happy to be here with you today. And what we'll be covering is just an overview of sustainable concrete design. And as Kelly said, this is sponsored by NEW, ACI Center of Excellence for Carbon Neutral Concrete, and that's one of the terms we'll talk about today. All right. We're going to talk about a couple different things. I'm going to start out just giving you some information about what I would call the lingo, but all the terms that are around sustainable concrete, carbon neutral concrete, net zero, things like this. We'll focus in a little bit specifically on carbon emissions, talk about the full life cycle, and then we'll do our overview of sustainable concrete. I will say that most of this is a pretty high level overview. At the same time, I think all of us find that we know a lot about a slice of a lot of these types of things, depending on how we've been exposed and what our focus area is. So I'm going to do kind of the higher level overview, but hit all the topics. So for some of you, it's going to be old news and you've heard it, but there might be some other things snuck in there that you haven't spent a lot of time working on. So I'm going to hit kind of a broader scope on this particular presentation. And I'm going to try to not overlap with what I know will be coming in the future on a couple of these topics. And then we're going to wrap up with what to expect next from what we're seeing in sustainable concrete, as well as what types of things you're going to see coming out of NEW as a center. Okay, so we've got the lingo here. These terms are everywhere. There's all different kinds of versions. And I think it's always a good base level to start talking about a couple of the terms specifically so that we're all on the same page. Most of these have specific definitions, and then other ones are a little more loose. What does green mean, for instance? Did a little word cloud here, but net zero emissions, we tend to shorthand things as carbon. I've circled down here in our logo, carbon neutral. What does that really mean? What are we trying to do? And so I'm going to start out with just a couple of these terms. And as we go through the presentation, I'll be adding some other ones in as we get into a deeper discussion. I think the first one that's hard is maybe not hard, but feels a little weird, is we keep talking about carbon. And we don't just mean carbon. It's really a shorthand, of course, for CO2 emissions. And more interestingly, it's not always just the CO2. It may also be the combined effect of all greenhouse gases that are converted into CO2 equivalents. So one of the things I think that's important as you look at data or you look at papers or you listen to presentations is see if you could find out, is that actually just CO2 emissions? Is it CO2 equivalents? What exactly are they measuring, and is there a baseline for it? Now, I will say in this presentation, I will talk about CO2 emissions fairly frequently. And in this case, because CO2 is the greenhouse gas that is the main driver for us in the concrete and cement industries, I'm really talking specifically about CO2 emissions rather than equivalents. But if I want to compare that in a broader scope, I would include the other greenhouse gases, and a lot of the national databases that you'll find will have CO2 equivalents, or global databases as well. All right, for cement and of course concrete, we're going to focus on CO2. Okay, I'm going to start out with what looks like a fairly complicated slide, but let's talk about carbon neutrality specific to cement. So two of the terms that I think are important here is, so we're a carbon neutral concrete center, right? So carbon neutral means that we're looking towards getting where we can have a neutral effect of CO2 emissions on the atmosphere, or carbon emissions on the atmosphere. You'll also hear the term net zero, which means there's going to be a release of a net of zero of the emissions into the atmosphere, of the CO2 emissions into the atmosphere. Those sound pretty similar, but I've shown a little diagram here. If you start at the top and we just look at what exactly do we mean. So let's take a basic process looking at cement and assume at this very start that we're using basically energy is coming from fossil fuels. And we, of course, know that a big portion of our CO2 emissions also, in fact, the majority portion comes from the calcination of limestone. Okay, these two on the left, this is going to give us our CO2 emissions. What we would need to get to carbon neutral would be to have CS, which in this case I'm calling carbon sequestration, or offsets, or something else that removes that same amount of CO2 so that I can get to zero. So I can still have emissions and be carbon neutral if I have sequestration, or I am absorbing or offsetting that emissions. Now, ideally, if we reduce this left side with the emissions, we get to a place where we use a lot less of this offsetting or the sequestration or storage or some of the other things, because that's not an infinite thing. We can't store infinite amounts, and we can't sequester infinite amounts, as well as, you know, purchasing carbon offsets and things. What we'd love to do is get this left-hand side smaller. The cement industry has already done a lot of work in this energy side, in using cleaner types of energy, updating plants, making sure this is as efficient as possible. So even if we were to get rid of all of the CO2 outside of the calcination, we'd still have some CO2 emissions from our current process of making Portland cement, but we'd have a lot less to offset or sequester or to store. Now, if we take the left side and somehow we're able to do a totally alternate material and come up with the same cement, for instance, and use clean energy, that would be net zero. We don't have to offset anything or sequester anything to balance that. So the difference between carbon neutrality is any of these give you carbon neutral. Only the bottom one is net zero, because there is zero coming out of the process to begin with. So that's a real challenge. That's obviously the high end goal, but the closer we can get to here, the less we're going to have on this right side. And that's where we'd like to go. What we have as a limitation, of course, is this calcination of limestone. So we're working hard on the other pieces of this right now. But as we go into the future, we're going to see some big innovations and new processes that may get us closer to net zero. Okay, I have to have my public service announcement in here, which I give to every student group, every community group, and even our friends here. You guys all know about cement and concrete. But what I want to enforce here, it's important that people in the general public understand the difference between concrete and cement. We know they're not the same. I use some version of this slide in talking anytime I have a chance to talk, because by assuming when the general public thinks these are the same, that's a real problem. And what we're seeing is more and more people outside of our industry setting policy. And that those folks, if they don't know the difference here, there's going to be some real unfortunate things happen to our industry because of not understanding the difference between the cement and the CO2 emissions from this piece versus the cement as a portion of the concrete or masonry or grout or whatever your flavor is. So don't let this pass by when someone uses this incorrectly. Okay, so let's just start out by taking the full kind of context of what we're talking about for concrete. So not just cement, but concrete. Let's use a concrete building, for example. What are we talking about when we're looking at emissions? So I use the example with the cement, and that is just a portion, of course. And that's only the portion that gets us to making the concrete. So if we look at the bigger picture, we have at the bottom here is our goal is that we want to know what are the CO2 emissions, what are we contributing in the CO2 emissions space from this whole life cycle of the building, right? Because the end goal is to reduce that. Doesn't matter what material we use, what we're doing, what the scope is. As a planet, we're trying to reduce how much CO2 is going into the atmosphere. And so to do that, we need to know the whole end game. Now, the way this is happening right now is the very tip of this, and that would be looking at the materials going in. So it's a good step because knowing the material piece contributes to the whole building, right? And what CO2 emissions we have to get that building in place. But even further down the line, we've also got the life cycle of the building, and that heating, cooling, lighting, maintenance, all these things are a huge portion. There's a reason this pyramid has such a big lower piece here. That life cycle is a huge contributor. Now, is concrete doing the heating and cooling? Probably not. There may be some contributions there, but if over the life cycle of the building, our concrete can contribute to reducing the emissions that we have or the energy usage that we have from heating and cooling, that is a huge step. Okay, so it's not just about what are the emissions from making concrete, it's from what are the emissions over the life cycle of a building or whatever structure you're using. And what is that life cycle? Is that life cycle 30 years, 50 years, 100 years, 200 years, where I'm going to have to replace or do major maintenance and overhaul? A couple things here. As we go up the line, I've put this in kind of an order where if we look at what's happening right now, so if you look at buy clean or some of the limits that are going in place across jurisdictions in the United States and globally, we will start to see things like for a given strength concrete, we're going to limit how much cement. The newer version is we're going to limit the global warming potential calculated for that concrete strength. What this is very prescriptive, which is probably not going to get us, or I know will not get us to the optimal solution. And it is very much the very tip of the iceberg here. This piece is not being approached yet. And so what we'd like to do is, okay, there's some things happening in here that we can work on, but we've got to keep moving in this direction. Setting a table with limits for global warming or amounts of cement use is a very temporary measure, and I would argue not probably the best path. But we've got to make sure that doesn't just turn into, well, we'll just keep lowering those limits. This is not going to get us where we need to be. We have to make big strides to get towards carbon neutrality. So cradle to gate, so up to the making of the concrete. Cradle to grave, if we just look at maintenance of the concrete building, et cetera, over its lifetime, concrete's a very resilient material, one that has strong durability. Those are all great things. And then the life cycle. So I hope as you start to see or talk about what's happening around prescriptive limits, that we are always focusing on this end goal of the full contribution. Okay, so You probably feel like this sometimes. This is one of the slides I really love. That is just gives you that feeling of we've got to do something, but there's so much. Just thinking about a concrete building is overwhelming, let alone everything that's contributing everywhere and where it does it count. And this thing's like, if I take one airplane trip to a conference, is that wiping out everything else I'm trying to do, and that sort of thing? The answer is you have to do something, and you start moving in that direction, and you remember the end goal. So similar to the triangle or the pyramid I just showed, we're doing something, but we need to remember that the way to get where we need to do and make these big steps is to consider as much of the whole as possible, and then scaffold in the types of things like EPDs and life cycle analysis and things like that to get there. I'm not going to talk about those two topics because our next webinar is going to focus with Dean Frank is going to focus very specifically into those. So stay tuned for that. But I feel like this slide is sometimes how we feel, and so I just throw it in the mix here. So what can we do? I'm going to talk about some of the things we can do, but most of this talk is kind of an overview. And I've just put these books up because that's kind of the basis for this talk. So this first one, these first two are a set of sustainable concrete guides. They are available on the newconcrete.org website for free. I was the author of the first one, along with a great editing team, and then lots of contributors that we put together for the applications guide. These were written well over a decade ago, but they still have good fundamentals. So if you're just starting in this area or you want a good overview, this is available to you on our website. And I'm going to hit some of the highlights of this first one during today's talk. We are in the process of the development of a third updated guide. We'll be updating the first two, but we're also going to have a new one looking specifically at carbon neutral materials and technologies. So the latest and the greatest of what's happening right now and where we think things are going and how likely some of these will come to play in the very near future. But I just put this up because I'm going to concentrate a little bit on some of the material from this first book to whet your appetite. All right, before I start on that, I just want to talk briefly about concrete as a material because I said, what can we do? Know that right now we've already got a lot of stuff going. There actually has been a lot of progress made. There's as I talked about before, reduction of the energy required to manufacture cement. We have been using pozzolans. We're starting to look more and more at alternative cements, partial replacements to reduce our CO2 emissions. In the future, we're starting to see some products that are actually cement, Portland cement, but that come from a different base material than limestone and potentially a different process or some variations on this. And of course, on the other end, if you think back to my chart, we've got carbon capture, carbon sequestration, things like this to help offset what is coming. So this is kind of the high level overview of concrete as a material, and that third book will help us flesh out a lot of this in more detail. So I'm going to spend some time here on just a big overview of sustainable concrete. I'm actually a structural engineer who dabbles in materials. So a lot of this book, when I put it together originally, talks about some of the structural pieces and less focused just on that cradle to grave gate of the material, but more of the higher scale overview. So I'm going to talk first about two terms, sustainability and resiliency. Talk a little bit about our natural resources, and then specific to concrete as a building material, and this use building loosely, it could be a parking garage, a building, other types of infrastructure, etc. But what are the benefits, particularly in this talk, I'll be focusing more on buildings, but why would I use concrete? And, why is this a good solution despite the CO2 emissions that we know we get? Okay, so let's start with sustainability and resiliency. So again, all these terms we talked about net zero and carbon neutral, we talked about CO2 emissions, we hear green, sustainable, all this. So terms like green and eco-friendly, those tend to be when people are talking specifically about environmental impact. Doesn't only have to be CO2, but it's some kind of environmental impact. And the fact is that gets interchanged a little too much with just sustainability. And sustainable is not only environmental. Okay, it's a three-legged stool. A long time ago when I was in school, we'd talk about the bottom line and we meant money. For a business, this would be equivalent to the triple bottom line. And this definition is also fairly old, from the late 80s, from the Brundtland Commission from the United Nations. This is one of the main accepted definitions, and that is that if something's sustainable, it meets the needs of the present without compromising the ability of future generations to meet their own needs. To truly be sustainable is pretty tough, right? There's not a lot of change allowed there. And there's always, you could argue that it's compromising the future in some way, shape, or form. What I like to think about with sustainability is that we're moving toward sustainability. And much like our carbon neutrality and net zero, the farther along that we can get, the better off we are. So I think the real key about when you think of sustainability is that there's three portions to it. There's the environmental portion, green, eco-friendly, things like that. There's the economy, and there's the societal piece. I'm going to talk a little bit about the societal piece. I'm going to talk about the environmental piece. I'm not going to talk as much about the economic piece because we've been living with that one for a long time and we understand it fairly well. And as we talk about life cycle, this would be the cost part of the life cycle. And these things are integrated because, of course, if I have a building that has a long life cycle, the cost during that over that life cycle is minimized, right? Or is the best return I can get. And that also happens to play in not using more materials. So there's a green component. The sweet spot in this Venn diagram where the three overlap, that's sustainable. Okay, you can have something that's economic and good for the environment, or good for the environment and society, but not economic. It takes the three of these together to be sustainable. Okay, how about resilient? You'll see stuff on the web. Is resilient the new sustainable? Look, they're different things, but they certainly tie together. Resiliency is an ability to recover from or adjust easily to adversary change, right? I want to be a resilient person. I want my plants to be resilient to drought, or, all the different types of meanings this word has. But it all comes back to this fundamental that you are able to recover, that you're able to bounce back. Okay, and there's going to be adversity, and we certainly are seeing this with some of the extreme climate events and extreme storms and things. This is a picture, if I recall correctly, is from Katrina, and here is a concrete house, and this used to be full of houses that are now gone. It is a big deal, in particularly as we see more and more, the 500-year storm is now a much shorter turnaround. And we see some extreme events, extreme winds, extreme temperatures, things like this. If we have a material that can stand up to that, that is not only important for maintaining services and important systems, it's also part of this not using new materials to start over all the time, right? If I have to completely rebuild, that is a very large CO2 emissions, it's a very large impact. And then think of the social piece and the economic piece as well, all those sustainability pieces. So that's how resiliency and sustainability kind of tie together. They aren't the same, however. Now, take this with a grain of salt. I've plotted a thing that goes from, on the far left, less resilient to more resilient, the far left vertical, less sustainable, up to more sustainable. You could, if you told a story behind each of these, they could fit in different spots, but as my slide, so I put together this story. And if I want to think about this, just because something's sustainable doesn't mean it's resilient. Just because something's resilient doesn't mean it's sustainable. Right? I can be resilient to the power going out and big storms and things by having a big old diesel generator in my garage and tons of fossil fuels stored. That does give me some resiliency, at least in the short term, but it is not particularly sustainable. This is an interesting one. So this recycled paper bridge is a fairly old, you can actually see the Pont du Gard in the background there in France. This is a recycled paper bridge that was part of a sustainability competition. As I joke with the students sometimes when I'm teaching a class, is not so great in the rainy season here. Yeah, it's recycled. That's a great thing. And, but is it really sustainable? No, if it goes away, after a rainstorm, that is very non-sustainable. It's also obviously not resilient. Okay. But a lot of people would look at this and say, who are kind of outside the know would say, now there, recycled paper, that is what we should be using. Well, we have to, it's possible if you can make it sustainable and resilient. Wood gets a lot of play for being, you can regrow it and being a sustainable option. This is a wood high rise. And, without going into a lot of backstory, this could be considered sustainable. I think that if you look at the life cycle, that would be one of the things you'd want to consider. But let's say this is a sustainable option. It may not be the most resilient option for a heavy storm and certainly for fire and some of these things. So, I'm not trying to promote any, I honestly am not trying to promote any material. I'm giving some examples on you might have a structure where you can deal with this, but in general, this strikes me as something that is less resilient to all the different types of things we're seeing with climate change and with extreme events, the droughts and things that are causing fire. Down here on the right, I've got something that I will call less sustainable. You have to know the whole story behind them to know whether they are or not, but less sustainable, more resilient. This is a structure that's built from those containers, all the rage, right? You get the shipping containers. So great. So if they're going to landfill or whatever, great. But you also have to build a significant roof structure with these. They are not great for heating and cooling in their current form as a steel box. And so you could say, yeah, this probably, depending on how this is put together, could be very resilient, but maybe not the most sustainable option. Then up here, not that every concrete building is perfect, but certainly here is a case where, whether this is a residence or it could be, you could have a similar form with a small office building, what have you, it is resilient. Is very much a concrete, it's going to deal with extreme events well. It's sustainable from the standpoint of it's going to have a very long life cycle. Heating and cooling, we'll talk about in a little bit, but a lot of the things we talk about having a long life cycle and what the real energy usage is in a building like this kind of reminds you of adobe structures or cave structures built into a mountain. Those had very good ability for moderating heat and cooling. All right, so I'm going to move forward on this, but the thing is that these two should go hand in hand, and what we're striving for is sustainable and resilient along this path. Okay, let's talk for a minute about putting this all in perspective. So a lot of what we talk about is new construction. We also will talk about repair and things like this. The fact is we have a lot of, in say the building, in buildings, we have a lot of buildings in place. I live in Duluth, Minnesota, which is a town that most of the buildings were done around 1900. So a lot of, quote, good bones in these buildings, but they need to be maintained. And then we have a lot less new construction and a lot more renovation and repair of those buildings in our building structures. If we look on the grand scheme, it's important to point out that new construction is going to use additional materials, right? So you're going to use the most resources and the most CO2 emissions. Now, when we have that, we should be doing all the things we're talking about to reduce emissions. But keep in mind, if there is an option to reduce the use of resources and reduce emissions from the very beginning, that's the best option. The next best is reuse it. Okay, so reduce means we don't start with new resources at all. Reuse is we're going to use it again in basically the same form. So I'm not going to need to do too much to it. Recycle is then breaking down a material into the components so that you can find new use or a new type of component for that. I bring this up because it's good to keep this perspective that you don't go in and say, you know what, we're going to tear it down. Not doing that in the first place is ideal. Sometimes it's unavoidable, or you're looking at an area that, you know, maybe it's a brownfield that you've recovered and you're doing some new construction there. The other reason I put this is in order, and you can think of this as a pyramid as well, is, you know, recycle, recycle. If you talk to a kid and you say, or at least a lot of the kids I'm around, if you say, how can I be green or how can I help the environment? Recycle has been drilled into them. This is not the highest level on the chain, right? Recycling my t-shirt is not as good as having someone else decide to wear it or me continuing to wear it while it still has life in it. So just to keep a good perspective on the hierarchy here of how this works. Okay, I'm now going to switch into talking about concrete as a material and how, and a couple terms around that. So why concrete can make a lot of sense in a lot of the applications we're talking about. Let's just talk about energy use in general. So I talked earlier about the full life cycle being so important. So if I look at energy use, I've got two pieces where I'm using energy, basically to make it, that's the embodied, and then to operate it, particularly in a building that needs heat and cooling. And that heating and cooling need continues to get more and more aggressive as we see hotter temperatures or essentially extremes, hot and super cold. That operational piece is the majority, and that operational piece has a lot to do with your building enclosure. Okay, I need less energy for heating and cooling if I have a good enclosure. I would also like to have efficient fixtures, appliances, and efficient practices by the user. Okay, I keep my house pretty cold because I can wear a blanket. Those types of practices can also help. Renewables, you know, that's also a good energy source. You have solar panels on the roof, things like this. And then incorporating a passive effect. So let me hit these two real quick. So incorporating passive effects is using the enclosure and some of the materials in the building and the circulation of air to the most advantage. A couple of these that concrete actually does well on is thermal mass. And the use of kind of passive solar. So I'll take a separate slide and look at this. The enclosure, there's a couple key things here. My thermal resistance and my sealing of the structure, and then a part of that is avoiding thermal bridges. If we look at a heat map of a typical house, you can see the studs, right? So red is where it's leaking, which windows make sense unless you have really, really high R value windows, and even then, there's going to be some heat or cooling loss there. The studs are bridges from the inside to the out. So when, you know, someone in my family, my husband often says, "You're heating the outside," to my son. We are, you know, so you can see where this house is heating the outside. And the less of this bridging from inside to outside, this direct escape of heat or cooling, the more effective that enclosure is. So I'm going to talk a little bit about that as well. Let's talk about thermal mass. This is actually a very important piece where concrete contributes. And I feel like the more extreme our temperatures get, the more important this is. This picture on the right is just a picture of a column of a building that's on campus near where I live. The whole structure is concrete. You go in, again, I'm in Duluth, Minnesota. You can go in on a -20 day, and there's a lot of passive solar through window and daylighting in this building, and touch this column and it'll be warm. Okay, even on a -20 day, it retains the heat that is given to it by the building or from the sun. If I have something that has high heat capacity and low thermal diffusivity, we'll talk about those in just a second, that is a material that has good potential for thermal mass properties. So heat capacity is how much I can store, And the diffusivity is how much it transfers. So if I can transfer that heat over slowly, you'll see how that affects it because it'll slow down that cycle. And the capacity of how much heat and I'm able to store also will affect that. Concrete has good heat capacity and fairly, relatively to other materials, pretty good low diffusivity. In other words, it transfers heat relatively slowly. Most importantly, our concrete applications tend to have very high mass. So this thermal mass effect can be significant. If I have concrete in place with this thermal mass, it can help me reduce spikes in temperature. It can delay the effects of those temperatures, and it's really great with passive solar. And I'll show you a slide with that. And what that means is reduced energy demand for a couple reasons. Let's look here at a couple of these. Sun or passive solar, if I have that coming in from the outside, like onto that column in that very daylit building, that building barely during the day, unless it's dark during the day, almost needs no lighting. It has great passive solar and daylighting. That is absorbed into the concrete and then released over time. So during the day, if this heats up, when it gets very cold here at night, it's almost acting like a battery. We just don't have a lot of on-demand storage, but it is slowly releasing that heat during the colder parts of the day. Same thing can happen with a fireplace or other heat stores inside. It can absorb that and then release it over time. So it's able to store a lot and it's able to release it fairly slowly. So there's a difference between when it is heated up and when that heat is released. This gives you an example. If I have a temperature, outside temperature, that is cycling, right? So this is the green, highs and lows. Inside, if I have a high thermal mass concrete type structure, this will shift when the peaks happen, right? You see how the peak is shifted? There's a lag. And they also are not as tall. The more thermal mass, the more I can shift that peak and the less of a spike I have. If I take off the spikes, that's a lot less energy for heating and cooling. And in a lot of places, including where I live, you are charged more during peak times for energy. And in fact, you can sign up for a plan where you are not on the peak demand side. It also, in places where that peak demand causes blackouts and other things, this is going to shift your need. And so that helps with cost as well as keeping the infrastructure intact for the electricity grid, as well as reducing these spikes means a lot less energy being used to begin with. Just briefly, this is a lot of words on this one, but in all climates, this thermal mass can help, okay? It really helps in hot, dry climates, and that's what we're looking at a lot right now. We've got hotter and hotter situations. We get drier and drier, droughts, things like this. Very high potential for energy savings. The thermal mass is returning the heat flow during the day and radiates that heat back out during the night. If it's hot outside and it's cooling off somewhat during the night, as I open the windows and let that heat escape, this will help. So both in extreme heat, extreme cold, but particularly this can help in an extreme heat situation. Then you ventilate well. Okay, you have to have the air to be able to blow through, exchange that inside air at night with cool outside air. Okay, so this seems far beyond concrete, but this is a big contributor that concrete can have. Okay, what other factors? Let's talk about the social type factors. It's not all social, but both environmental and some comfort and aesthetic type things. Other factors that we have here are acoustics. I'll talk about those. Daylighting, air quality, heat island effect, and aesthetics. I'm going to leave aesthetics to you and not cover that in this talk, but it is one of the factors. Okay, acoustics. So I'm covering some stuff that you don't hear about every day in sustainability, and that's the point of this presentation, is this sustainable three-legged stool that covers more than just the environmental, although the environmental is, of course, very important. So acoustics. We're interested in quality and sound quality. So if I'm giving a concert, I have a certain sound quality that I'm anticipating, and also in reducing noise. So here's a picture, of course, of a sound barrier. High mass materials help reduce transmitted noise. So if I have a concrete wall between me and the next room in the hotel, that's a lot better at reducing that noise transmission between rooms than many other materials. Of course, we don't have all interior concrete walls there. But if I have external concrete walls and outside noises are significantly reduced. I have been working in a building here that has uh, structurally insulated panels, sandwich panels, and the whole building exterior is concrete walls. If there's a storm or thunder and lightning, or it's actually right near the airport, jets going over, you do not hear it inside this building. The transmitted noise is very, very low. The other piece is reflected noise. So a nice smooth finished concrete surface is going to reflect. So if I am trying to have a talk in an auditorium that is solid, shiny surfaces, that's not going to be what I want. The noise will be reflected very well. So I use absorbing or texture materials. You'll notice on a sound barrier, what they're doing here is they've got some texture to this, some different surface to reflect in different ways, as well as just the absolute reduction of transmitted noise. So some things to think about as you have a building and you start using more bare surfaces, and I'll talk about that because of air quality. There's aesthetic components, there's noise reduction, and there's noise reflection components that are part of this as well. Daylighting. This on the right is that same building I was talking about with the concrete columns. Extensive amounts of daylighting and passive solar in this building. Very effective, great on the energy bills here, and it's a very welcoming building to be in when it's 20 degrees below. It's a very, and it has a lot of exposed surfaces without a lot of paint, which I'll talk about in air quality. So daylighting or heat island effect. So this is also a big deal. So if I've got a concrete parking lot here, or pavements or parking lots, and that ability to reflect the light rather than absorb the light is a lot of difference in temperature. So if I have a, asphalt versus concrete, or dark material versus lighter material, particularly in a city where that is compounded, and you can look up heat island effect and learn a lot more about this, but this is significant. It really changes the temperature at the surface and everything around it. And in a metropolitan area, it's very significant. So we do have also this going for us as a material, particularly the lighter colored concretes. And this is coming up more and more in the desert climates and the extreme heat areas. Another benefit we have, and some of these are commercial, some of these are residential, but look, concrete's a neat material because it can be easily molded to any shape. You can add color within it without having to paint it. You can stamp it. You can do all kinds of things, right? These natural finishes are important because you are reducing the use of paint and volatile organic compounds. You're reducing the maintenance because you're not painting. As well as you're able to get some beautiful surfaces for the aesthetic piece without someone wanting to paint or add some kind of maintenance to this material. So this maintenance-free piece is a really important component as we move forward as well. Okay, so whether that's a bridge or that's a, actually nothing pains me more than seeing a concrete bridge painted rust colored, but that's another issue. These natural finishes are a big boon for air quality. I've worked in a building at the university that is all natural finishes. It's a LEED gold building. I have extreme allergy issues, and I literally am healthier in the building that I work in than I ever was in any other building on campus. It's very noticeable, and there's not really carpet anywhere. everything's open and there's some noise reduction type things in some of the rooms that need it, but otherwise it's a very healthy environment. Okay, so that just gave us some highlights. I'm going to go ahead and wrap up here. What's on the way, right? So we are seeing right now already legislation with global warming potential limits. You're going to see that starting to, you're seeing a push to track that to zero with time. So we need to think about how we do that, and do we want really prescriptive limits? Is that going to get us to where we need to be? So I'm not pushing back that we need to get to carbon neutral. What I'm saying is we need to think about the long haul of how to get there. Okay, one little increment is not going to do it. We need to think a little bit in a more systems perspective. We're going to see large scale implementation of the things we already do. So limestone cements, cement replacement, pozzolans, anything around that piece, you're going to see bigger and bigger implementation of that to meet some of the legislation that's going into place. You have big owners and little owners too, targeting their own carbon neutrality goals. So if an owner is targeting for, and it's a large scale owner that's targeting all their to be carbon neutral, say by 2040 or 2050, their infrastructure has got to be a big part of that, and they will help drive some of the goals around carbon neutrality. And we're going to see that more and more as we get closer and closer to those end dates. We're also going to see significant innovations in material and processes. We're already seeing this now. What's hard about our industry is scaling up from where we are as an idea or a pilot into full scale. We are a regional based material, a very large industry with a lot of moving parts. And so at some point we are going to be where, I've got no turning back and moving forward. At some point, the tipping point's going to happen where we have to, it'll be worth investing in some of these big, riskier innovations so that we can get where we need to go. And I think that that's probably on the horizon. So I am wrapping up now, and I will open up the floor to questions if you have any. Here's all of our places where you can find new, and we will be having more webinars coming up in the future that will go into much more depth about some of the topics that I talked about today. So I'm going to check our Q&A and see if anybody's got anything. You're welcome to ask. Not seeing anything pop up quite yet. I think the thing that I would just mention is, watch for what you're seeing in your region and in your area. Watch your kind of local or your jurisdictions. And if you can contribute to the discussion and help with the knowledge of how we use concrete and how our industry works, I think that's important. We need to change processes in the whole construction industry. We're going to have to move and continue to move towards carbon neutrality. And it's important for the people at the table to understand the depth of those types of questions and those and our industry. All right, I'm going to turn my camera back on here just for the end piece in case anybody has any questions that show up, and oh, there's one. So I've got a comment basically saying they wanted to hear work about the low carbon concrete. This is older information. Yeah, definitely. As I said, this isn't a big picture overview. There is a lot happening, and we will be having some more webinars on lower carbon concrete. So stay tuned with that. And there are resources available on the website. And you're right, there are a ton of opportunities. I'm not sure who was able to attend the last webinar where our executive director talked, but one of the big things we're seeing is NEW will be dealing with validation and assessment of some of these more innovative new materials and processes, because right now there's not a place to do that type of work so that it's a little easier for people, particularly outside our industry, to know what really does make a difference versus what, that has data and things behind that. The slide with the doodle was great. Do we have a similar one to show all the different ways to reduce CO2 for the building? Yeah, and actually you're going to see some of this when Dean Frank presents on LCA and EPD. But yeah, for the reducing CO2 for the building, it depends on if you're talking about specifically for concrete or some other things. There's the material itself is always there. There's the energy use in the building itself. And so there's a lot going on in that piece as well. I tried to cover some of the things specific to concrete, but there's obviously a ton of different things that can be done, and there's a lot of information available on the web. I'm not sure if you mean specifically for concrete or for some of the other pieces. All right, I'm going to wrap up. I know that we're getting close to time, so I appreciate everybody who contributed today, and thank you. And we will get this loaded on the web. And these presentations will get to continue to be a little more in depth as we build the resources and move along. All right.
Okay, everyone, please visit the new website at newconcrete.org for more information on this topic. While you're there, please check out our resources on lower carbon concrete production and placement. The website provides access to our sustainable concrete guides, frequently asked questions, webinar recordings, and more. Thank you again for attending today's webinar. If you haven't done so already, please check out our other great webinars scheduled. Thank you again and have a great day.
Thanks, everybody.